and welcome. Today we're going to be looking at interpreting nonlinear expressions. As always, we're going to be going through 5 questions, explaining them and looking at the intricacies of this topic so you can ace the SAT math portion. We're done. We finished the heart of algebra and we're now on the passport to advanced mathematics. If you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get started. Question number 1. We're told that P of M equals 100 times 1/2 to the M over 27. And we're asked to interpret, we're told that bismuth 199 is a radioactive isotope that decays over time. The half-life of the radioactive isotope is the amount of time it takes for 1/2 of the isotopes in the sample to decay. The function above models the percent of bismuth 199 remaining in a sample after M minutes. What is the meaning of the number 27 in the function? Well, first, let's figure out what the half-life is. So the half-life is the amount of time it takes for the sample to decay by 1/2, right? To lose half of it. So it gets multiplied by 1/2. Well, it gets multiplied by 1/2 when it says 1/2 to the 1, which means that M over 27 is going to be 1. So M is then going to be 27 minutes. So that 27 conveys the half-life. The 27 is the half-life, essentially. Right? After 27 minutes, it's going to be 100 times 1/2 to the 1, which is going to be 50, which is half of what you started with. So the half-life is 27 minutes. So therefore, the answer is D. The half-life in bismuth 199 is 27 minutes. Let's keep going. All right, question 2, and it is D equals 32 times 1.16 times q to the 4th. The equation above models a total number of downloads in thousands D of a mobile game Q quarter years after it officially launches. Based on the model, which of the following statements is true? Well, let's see. So every year, right, you have a Q equals 4 for every year, right? Because Q is Q quarter years, right? So which means that 4Q is 1 year. So each year, right, Q increases by 4. And since we're starting at 0, then it would go to 4. Or if we're starting at 4, it would go to 8. So then how does D change then? Well, you're adding 4 to Q. So then it would be like 32 times the 1.16 times like this, right? It's 32 times the 1.16, right? But really, it would always be like this, right? So this is for the first time from 0 to 4. The second time, it would be 32 times 1.16 to the 8th. And then 32, or no, it wouldn't, it would be, to the second, it would be 8 over 4. And the third time would be 32 times 1.16 to the 3. So every year, we multiply by 1.16. But what is multiplying by 1.16? Multiplying by 1.16 is the same as a 16% increase. A 16% increase, and therefore our answer is choice A. The number of total downloads increases by 16% each year, each full year. So our answer is A, and we are done. Let's move on to the next question. And well, it looks complicated. E to the ES equals 6.11 times 10 to the 7.5 T over 237.3 T plus T. All right, and we're told that the saturation vapor pressure over water ES measured in hectopascals is the vapor pressure of air when the number of water molecules condensing equals the number of evaporating flat surface of water. The equation shown above models the relationship between ES and the temperature T in degrees Celsius of the air and water. Which of the following best describes the meaning of 6.11 in this context? Well, 6.11 could be the saturation vapor pressure of water, part was 1. This part was 1. Right? So how do we get that to be 1? Well, if 10 to the x, say, is going to equal 1, then the x is going to have to be 0. So that means that this 7.5 t over 237.3 plus t has to be 0, which means that t has to be 0. So the temperature is 0 degrees Celsius. When the temperature is 0.0 degrees Celsius, then x is 0, so 10 to the x is 1. Oops. 10 to the x is 1, and then this becomes 1 right here. So then the saturation vapor pressure is 6.11 when the temperature is 0. So saturation vapor pressure when temperature is 0 degrees Celsius is answer choice A, and we can move on. Look at the next question. All right, next question, and it is the following equation shows the number of possible distinct passwords P of length L. Each character is selected from the n permitted characters. How does the number P of possible distinct passwords change if the length is increased by 3 characters? Well, we can start with n to the L, and we go to n to the L plus 3. That's essentially what's going on. Now, n to the L plus 3 equals n to the L times n to the L. So we're really just multiplying by n to the 3 n cubed, which is answer choice A. And let's move on. All right, question number 5, and here it is. The equation below can be used to calculate the kinetic energy K of an object having a mass m and a velocity v. If the velocity of Nicola's car slows down to 2/3 of its previous velocity, what will be the effect on the kinetic energy of the car? Well, let's see. The mass stays the same, so I don't really need to care about that. So we start off with K, which is the 1/2 times mv squared, and we end up at 1/2 times m times 2/3 v. 2/3 v squared. So 2/3 squared is 4/9, so we're really just multiplying by 4/9. So end up with 4/9 K as our final kinetic energy KE. So our answer is then going to be answer choice B. The kinetic energy will be 4/9 of the previous amount, and that is our answer. That is it for this topic. Be sure to tune in and we continue our study of the passport of advanced mathematics. This topic was kind of simply literally just calculating the difference between various different conditions. Essentially, the main concept in this topic is simply you express the change in terms of the variable, and then you plug that back into a formula you have, and you figure out how it's going to change based on other changes. You just use the algebra, you apply the algebra to find a change in various conditions, and that is all this topic is about. This is it for this topic, and I'll see you next time.